Hello friends, welcome to the session on multivibrators. In this session, we'll be discussing how a transistor can be used as a switch. In this session, we will see what we mean by transistor as a switch. We will see what we have to make the arrangements so that the transistor can work as an off switch and on switch. And also we will see where the transistor is being used as a switch. Friends, you know that you are viewing this session on my YouTube channel, Learn with Prakash Kanale, and do subscribe to the channel to see many more videos on the subjects of electronics and computer science. So let us start the session with the question, what we mean by transistor as a switch. As you can see in this diagram, that when we study the characteristics of the transistor, then we can plot these characteristics as shown in this figure. On the y-axis, we have taken the collector current IC. On the x-axis, we have taken collector to emitter voltage. IB is being varied from the value 0, and in steps it is increased in microamperes. You will find that for a fixed value of IB, as VC goes on increasing, IC also goes on increasing, and then after certain amount of IC, you will find that the IC will almost become constant. That is, the collector current will almost become flat as shown in this figure for the given IB. Now, we can easily observe that such characteristic curve will give the three possible regions of the operation of the transistor. The region below IB is equal to 0 is being called as the cutoff region. The region for which the collector current IC is maximum is being called as the saturation region of the transistor. And in between cutoff region and saturation region, we have another region, and this region is being called as the active region of the transistor. So we can easily observe from the characteristic curves of the transistor that the transistor can be operated in three regions. The first region is being called as a cutoff region, and in the cutoff region, the base current IB is equal to 0, and hence the collector current IC will also be equal to 0. In cutoff region, you can easily observe that both the junctions of the transistor, that is base emitter junction and base collector junction of the transistor, both the junctions are reverse bias, and therefore no current can flow through the transistor. Another region of the transistor is being called as an active region. In active region, the base emitter junction of the transistor is forward biased, but the base collector junction of the transistor is reverse biased. So whenever we want to use the transistor as an amplifier, then it is necessary that we should keep the transistor only in active region. The third region is being called as a saturation region. In saturation region, the base emitter junction of the transistor and the base collector junction of the transistor both are forward biased, and therefore the collector current that is flowing through the transistor is maximum, and this is being called as the saturation value of the collector current. Now, as I said, whenever we want to use the transistor as an amplifier, then it is necessary that it should be operated in the active region only. So for this purpose, we will make the biasing arrangement to the transistor in such a way that the transistor will always remain in active region. But when the transistor is operated in cutoff region, or when the transistor is operated in saturation region, then it no longer can work as an amplifier. In such a case, the transistor works as an electronic switch. In cutoff region, the transistor works as an open switch. That is, no current flows through the transistor, and therefore the resistance between collector and emitter of the transistor is very high. In saturation region, the transistor works as a closed switch, and therefore a high amount of current will flow through the transistor, and therefore the resistance between collector and emitter of the transistor is very low. You will find that whenever we want to study multivibrators, then it is necessary to understand these characteristics of the transistor, because in multivibrator, a transistor is always used as a switch. So in multivibrator circuits, the transistor is not used as an amplifier, but it is used as an electronic switch. The characteristics of the transistor as a switch is very important to us because it is possible that by using the transistor as a switch, we can control the lamps, relays, and even motors. Transistor is not an ordinary mechanical switch. You can easily observe that the transistor is an electronic device, and therefore when transistor is worked as a switch, then it works as an electronic switch. It means that this switch can be operated 1,000 number of times in a very small amount of time. That is, in 1 second, we can make the switch on and off even 1,000 or even more than that times. Now let us see how the transistor works as an off switch. Suppose we have been provided a transistor, NPN transistor, and the emitter of the transistor is grounded. And suppose the base is connected to the base resistance RB, and base is also connected to the ground since we have applied 0 volt to the base. In such a case, the base current IB will be equal to 0 and the collector current IC will also be equal to 0. Now in such a case, if you measure the resistance between emitter and collector of the transistor, you will find that the transistor will offer a very high resistance. And therefore, we can say that the transistor works like a off switch or open switch. So here, in order to work the transistor as an off switch, it is necessary that the base voltage of the transistor must be 0. The base current IB and collector current IC of the transistor will also be equal to 0. Now, in such a case, both the junctions of the transistor will be reverse biased and no current will flow through the transistor. And we can say that the transistor is in the cutoff state. The resistance, if it is measured between collector and emitter, then this resistance is very high and it can be given as R off is equal to VCC divided by ICEO, where ICO is a small amount of leakage current which is almost equal to 0. So in such a case, the transistor works like a off switch or open switch. Now suppose we want to use the transistor as an on switch or closed switch. Now as shown in this diagram, consider a transistor. To the base of the transistor, suppose we have connected a positive power supply plus VBB. Now the large amount of base current will flow through the transistor and it will cause a large amount of collector current to flow through the transistor. In such a case, if you measure the resistance between the emitter and collector terminal of the transistor, you will find that this resistance will be very, very low. And therefore, we can say that the transistor works like a on switch or closed switch. So here we have to apply a positive base voltage to the transistor. A high amount of base current will flow through the transistor, which will cause a large amount of collector current to flow through the transistor. This current is called as the saturation current of the transistor. In such a case, both the junctions of the transistor will be forward biased and the transistor will be in the saturation state. Now, if we measure the resistance between collector and emitter of the transistor, then you can find this resistance is equal to VCE saturation divided by IC saturation, where VCE saturation is a very low voltage, almost equal to 0. And therefore, in such a case, we can say that the transistor works like a on switch or closed switch. So as shown in this diagram, if we plot the curve of IC versus VC, then this is the point where you can say that the transistor is working like a closed switch and the amount of collector current will be maximum, which is flowing through the transistor. Now, this is the point where you can say that the transistor is in the cutoff region and the collector to emitter voltage of the transistor will be almost equal to the supply voltage and collector current IC will be equal to 0. That is, to the transistor, when you apply a square pulse, then you will find that the same square pulse you will get at the output. but the only thing is that the pulse will have a phase difference of 180 degrees. So when the input to the transistor is 0, then the transistor will go into the cutoff state, and therefore the drop across the RC will be very, very low, and therefore the output will be high. When a high input is applied to the transistor will go into the saturation. A large amount of collector current will flow through the transistor, and therefore almost all supply voltage will be dropped across the RC, and the output is low as shown in the figure. So thank you friends for viewing the session. Hopefully you have understood how the transistor works as a switch. These characteristics of the transistor is used in the multivibrator circuits. In our next sessions, we will see the different types of multivibrators. Thank you all for viewing the session.